What if I told you that you could analyze 100,000 riser configurations in just a few seconds? Today, I'm going to show you how the Lazy Wave Riser module in Offshore Dynamics transforms weeks of engineering analysis into minutes of real-time exploration. Let's dive in. First, we select our vessel. In this case, an FPSO. Now watch this. I can adjust the cable departure point relative to the vessel's center of gravity. As I move it, every single riser configuration updates instantly. No waiting, no manual recalculations. Everything stays perfectly synchronized. Here's where it gets powerful. The system automatically generates 6 complete configurations: flooded risers, empty risers, near offset position, far offset position, and combinations of each. Now let's talk about control. Every parameter is at your fingertips: sag and hog geometry, departure angles, line weights, buoyancy ratios, product content, whether that's oil, gas, or water. And here's the magic. Change any of these parameters and watch as all 6 configurations recalculate automatically. The Lazy Wave geometry adapts in real time, maintaining physical accuracy across every scenario. Before we run a full operability study, let's validate our setup. I can specify any wave condition: a 100-year storm, a 10-year event, even a 1,000-year extreme, and instantly see minimum and maximum tensions, curvature distributions, and touchdown point excursions for all 6 configurations. Simultaneously, this is engineering insight that used to require running Orcaflex simulations overnight. Now, it's instant. Now let me show you the real power of this system. I'm setting up a complete operability study. Wave directions from 0 to 360 degrees every 30 degrees. Wave periods from 5 to 15 seconds. Significant wave heights from 1 to 12 meters. That's 35,000 individual cases. I set my constraints. Minimum bend radius 5 meters. Tension limits -30 to 500 kilonewtons. Normalized curvature 1. Now watch. Done. In seconds, we have a complete operability matrix showing the maximum allowable significant wave height for every direction and every wave period. But we don't just get numbers, we get understanding. Hover over any cell, and the system tells you which configuration is limiting, why it's limiting, whether it's tension, curvature, or minimum bend radius, and the exact values at that operating point. See this cell? The system shows us that the empty far configuration is failing due to maximum tension. This isn't just data. This is actionable engineering intelligence. Let's say we need to tighten our tension constraint. I'll drop the maximum to 400 kilonewtons and recalculate. 35,000 cases, recalculated, instantly. And look, the operability has changed, and tensions are hitting 398 kilonewtons, just under our 400 limit. We can immediately see the impact of that design decision across the entire operating envelope. But why stop at 35,000? Let me change the direction step to 10 degrees instead of 30. That's now 100,000 cases. Done. 100,000 Lazy Wave Riser simulations. Complete operability assessment. Every direction, every period, every wave height. In the time it took me to explain it, the analysis was finished. This is the future of offshore riser engineering. What used to take weeks of simulation time, countless Orcaflex runs, and massive computational resources, now happens in real time, right here in your browser. The Lazy Wave Riser module doesn't just speed up your workflow, it transforms how you approach riser design. You can explore, you can iterate, you can optimize, because when analysis is instant, innovation is unlimited. Offshore Dynamics, engineering at the speed of thought.